Okay, so we are going to keep going with a different way of doing these limiting reactant problems. The way that we have been doing these problems, so for example, this is the last practice problem that we did, was by taking the amount of both reactants and basically figuring out how much product can be made by each. And that is one way of getting the answer, and it's relatively straightforward, but it's not the one that is used the most often. Most often, if we were doing this without stoichiometry, without chemicals, and we were doing it with actual, like the cooking examples, we wouldn't really do it this way. This is more similar to what the second way that your Pogel explained. And I'm just going back to these pictures. They're in your notes. If you go back a few pages, you can just look at these examples up here. But basically the question that we're going to keep asking ourselves over and over again is, do I have enough of the second reactant to use up all the first? So for example, and that's the question that you're going to ask yourself every single time. Do I have enough of the second reactant to use up all the first? So do I have enough tires to use up the 8 car bodies? And so in your head, you have to do a little math and you have to figure out, well, since there are 4 tires for each car, if I use 8 car bodies, I would use 32 tires. I have more than enough. So the tires won't run out, the car bodies will run out. And then that's the limiting reactant, right? This example right here, if we look at how much we have, right? Do I have enough? Here's right, this is what we have. Do I have enough of the second and third reactant to use up all of the bread? So in my head, I'm saying, well, if I have 6 slices of bread, right, I'm going to need, so 6 bread, according to the balanced chemical equation, right, according to this, I will need 3 pieces of lunch meat for every 2 slices of bread. So therefore, 6 times 3 is 18 divided by 2. I would need 9 pieces of lunch meat. Well, I have 12, so I have more than enough lunch meat. If I start with 6 slices of bread, how much cheese will I need? Well, this tells me for every 2 slices of bread, I would need 1 cheese. So that means I would only need 3 slices of cheese. I have 5. So I have more than enough of the lunch meat and more than enough cheese to use up all my bread. So bread is the limiting reactant, right? How many buns do I have, or how many buns do I need to use up all my hot dogs? Well, if I have 5 hot dogs, and the ratio, right, I would need 1 of each. So I would need 1 hot dog. I would need, for every 1 hot dog, I would need 1 bun. So in order to use up all of my hot dogs, I would need 5 buns. Look at how many buns I have, though. I only have 4. So therefore, buns are my limiting reactant. Okay, that's what we are going to, or that's how we're going to approach these problems, right? So these can get a little bit tricky. So if you get confused, kind of go back to the picture ones. Do I have enough of reactant 2 to use up all of my first reactant, reactant 1? So here is the problem that we're going to be looking at. Copper reacts with sulfur to form copper 1 sulfide according to the following balanced equation. So there's the balanced chemical equation there. What is the limiting reactant when 80 grams of copper reacts with 25 grams of sulfur? So step number 1 is going to be the same. Step number 1 is going to be, for both of those, trying to figure out how many moles of each we have. So we just start with one reactant, convert it to moles, start with the other reactant, convert it to moles. Then, so this is step number 2. Convert the moles of copper, so this would be reactant 1, to moles of sulfur, so this is reactant 2, that is needed. So you can see we put reactant 1 out here. I'll just label these reactant 1 and reactant 2. And then I use the coefficients from the balanced chemical equation, right? And I figure out how many moles of reactant 2. And this is what's key. What is this number? That's the number of moles of the second reactant that I would need to use up the first reactant. So this is saying, if I was going to use all 80 grams of copper or all 1.26 moles of copper, I would need to use 0.630 moles of sulfur. And then you compare these two numbers, right? So if I look down here, this is step number 3. Compare the amount of sulfur needed to the given amount of sulfur. So look at these two. What I'm comparing are moles of sulfur. I'm comparing the same chemical, but this is how much I have, and then this is how much I need. Again, why do you need it? To use up all of reactant 1. So this is telling me I'm going to need to use 0.6 moles of sulfur to use up all my copper. Look at how many moles I have. I have 0.779 moles of sulfur. So I have more than enough. So since I have more than enough sulfur, right? More than enough is another way of saying excess, right? So since sulfur is in excess, the other reactant, copper, must be the limiting reactant. So you're going to have to do some logical thinking here to think and really compare about needed to use up all the first reactant and how much I have. After we get to that point, right, we can actually finish the problem if it asks me for an amount of product, right? So then you can see I wrote this one for you, right, in order to use up all of the copper. So we always, start with thinking what we're checking is reactant 1 my limiting reactant? And this says in order to use up all of copper, 0.630 moles of sulfur will need to be used at the same time. Since we have, look at how this number right here, this is how much I have. The sulfur won't get completely used up because I'm only going to need to use 0.6 moles. And so therefore the copper is the limiting reactant because the sulfur won't get all used up. And then once you know which substance is the limiting reactant, use that one in the answer to your stoichiometry problem. So if we were to answer the rest of this question, right, how much of the product, how much copper 1 sulfide could be produced? And so now you don't have to do 2 full stoichiometry problems. We've figured out that the 80 grams of copper is the limiting reactant. So we can start 80.0 grams of copper, convert that to moles, and then using the coefficients from the balanced chemical equation, 1 mole of Cu2S will require 2 moles of copper. And the question is asking what mass of copper 1 sulfide. The molar mass for that is 159.17 grams of Cu2S for every 1 mole of Cu2S. Right? And again, let's remember how to do these stoichiometry problems. I make sure that diagonal down matches. The only place I use the coefficients is in that middle mole over mole parenthesis. And the calculator gives me 100.185 grams. Right? That 80.0 has 3 significant figures. Of course, my 2 molar masses have 4, so I'm going to round my answer to 3 significant figures, which is going to be 100 with a decimal point grams of Cu2S. So let's review the steps that we did to get this answer. Right? What I did was first is I converted both to moles. So step number 1 is going to convert both of my reactants to moles. Step number 2 is converting moles of reactant 1 to moles of reactant 2. And you're going to use the coefficients from the balanced chemical equation to do that. That's down here. And then the third step is not really a math step. It's a logic step. And it's comparing, right, need versus have. And this makes, in order to, you really need to understand what's going on, what these numbers represent, in order to understand what this question, or which one is going to run out first. And basically what you are checking is, do I have enough of reactant 2 to use up all of reactant 1? So you're comparing how much you need versus how much you have. Okay? So that's what you're going to think in your head. Do I, in this case over here, right, the needed was less than what you have. Then reactant 1 is the limiting reactant. But then, right, if your needed is greater than what you have, what does that mean? That means that I don't have enough of reactant 2 to use up all of reactant 1. So what that's telling you is reactant 2 is your limiting reactant. And it doesn't matter which one you identify as reactant 1 or reactant 2, the math will work out so that you always get the right answer for which reactant is the limiting reactant. So on the exam on this in a week or in a few days, you are going to need to show me that you can do these problems both ways. So the next couple videos are just going to be doing some more practice of these and working through some more problems.